select. So I'm going to hit the select button in the upper right, and I'm going to choose Linear Flight Mission 1. Actually, let me get rid of this one. I'm going to select this Area 1, and I'm going to hit the delete key at the bottom, and that will delete that other mission. Now I'm going to hit select, and I'm going to choose Linear Flight Mission 1, and down at the bottom left icon, the double square, that will copy that mission. Now I have a duplicate. So now I have Linear Flight Mission 1 and Linear Flight Mission 1 copy. So now I'm going to edit this one. I'm going to hit the edit button on the left side, and I'm going to make the change of it. So now we're going to change this to be L1. And we're going to change the camera from the Zenmuse P1 to the L1 LiDAR mapping. So now we're going to do a LiDAR mapping mission. Okay. The only thing that changed now is now it got rid of GSD, and now you see point cloud density, 141 points per square meter. Okay. We're on a little more density than that. Again, the minimum density I like to fly specifically for transportation is around 450 points. That's where I can start seeing details. The more dense you get, the more details you're going to get, but the slower it's going to take you to fly, and the lower your point cloud. So in photogrammetry, the only thing we have to worry about is altitude. There are a bunch of things that can factor into LiDAR. So let's talk about the LiDAR system and what it'll do. It is a LiveVox LiDAR that can select 1, 2, or 3 LiDAR returns. It can colorize the point cloud, so it can automatically colorize point cloud. It has 2 scan modes, repeating mode and non-repeat pattern. The repeating mode is a narrow band, high intensity beam that just sweeps back and forth, okay? And the forward motion of the drone fills in the density. The non-repeating mode sprays out in a spiral pattern, almost like a spirograph. Large area broadcast. You get better chance at randomizing your points to get through foliage in different angles, but you lose accuracy. Okay, so you're trading off accuracy for area and penetration. Okay, there's also return modes. So look, I got a low battery warning. That's this battery on the back.
Okay.
So all I gotta do is pop this battery off the back and put a new one on. Grab a new one for me. It's because this takes a lot of battery coming out the HDMI. So I've got repeat mode, non-repeat mode. I used to have a PDF. I don't have it anymore. I showed the pattern. Repeat mode, non-repeat mode. It's 1, 2, or 3 returns. If you're not familiar with LiDAR returns, when you shoot out a beam of LiDAR, it bounces off an object, it comes back. If it glances off an object, it hits a second object, that'll be the second return. And if a portion of that laser light hits and strikes 3 objects going down, that'll be your third return. You can select how many returns you want. First return is always going to be your top objects. So in canopy, it's going to be your top of canopy, top of everything. It's higher accuracy than 2 or 3 returns. Second return might get you the top of a tree in some place down the mid-trunk. Third return will get you top of a tree, someplace mid-trunk, and someplace in the ground. The more returns you have, the better chance you have of penetrating data, but the lower your accuracy suffers. So there's a trade-off. Also, the less number of points you put out. For a road transportation job like this, I would do 1 or 2 returns without doing 3, unless it's heavily wooded or there's a lot of overgrowth in the ditch line. Okay, in which case then I would go 3 returns. I'd probably always go 2 returns, never more than 3, unless, like I said, unless I need trees. So we're going to set up all of that affects density, because 1 and 2 returns ends at 240 points per second, 240,000 points per second. But as soon as you add that third return, it drops down to 168, so you lose density. Non-repeat pattern gives you a higher density pattern than a repeat pattern. There's a whole bunch of factors in there. So cloud density 141, let's start changing it. You can ignore GSD. All right. Again, that flight band section is just there for setting up your geometry. The flight route is where we're going to set up our mission stuff. So we're going to say flight route altitude First of all, we're gonna drop that down to maybe about 150 feet. I would start at 150 feet as your baseline for the LiDAR, and then move up or down as you need to avoid obstacles. Most trees are not any taller than 100 to 120 feet, so you can avoid most of those. Your biggest enemy are going to be transmission lines and, objects like that. As soon as I hit 150 feet, look, my densities are up to 314 points per square meter. Right?
So it has those avoidance this thing. So what if, like, as it's flying, like it runs into a bird or something?
It might not react fast enough to a bird. The bird's going to end up having a hard day.
Okay.
The drone's going to have a hard day too. It's probably going to fall out of the sky. The only birds that you have to worry about are swallows will dive bomb it. Hawks will try to take it down. Hawks and eagles will chase after it. Vultures will avoid it.
Okay.
Most big birds will avoid it. I really had an issue with that.
So what if it avoids something? Does it reset itself to get that picture? Or
It doesn't really avoid, it stops.
Oh, it just stops. Okay.
Yep. Yep.
Okay. So you have to take it up or down, or it takes itself up to avoid something, or
It stops.
Oh,
It just stops. It doesn't avoid it, it stops.
Okay.
The obstacle avoidance should be just basically object detection.
Okay.
Right?
All right.
It's consumer drones will go around objects. This
Sure.
one won't.
So you have to manually move it up. Okay.
Flight speed. So 11 miles an hour. Let's drop that back to like 10 miles an hour. And now my point density should be 714. So just dropping it 2 miles an hour took it from 358 to 700 points per square meter. You'll probably bump that up to 11 even. IMU calibration. So we talked a little bit about the inertial measurement unit, what maintains orientation of the drone in the sky. It needs a calibration before and after. So when you start your mission, it's going to fly to the start point, and it's going to fly at high speed forward and backwards 4 times over 25 feet. And then it's going to start its mission. IMU is like putting your finger in your forehead. After a while, it gets numb and you can't feel it anymore, so you kind of move it. So after long stretches, you can see the little yellow dashes that appear. It's going to scan, it's going to stop, it's going to back up and go forward again to kind of shake things up again and keep it going. Inertial measurement units require motion, okay? Or change in motion. So you always want that on. You're going to lose accuracy if you don't have that on. Under advanced settings, that's going to be your side overlap. We're going to just leave that alone. That's how much the scan is going to overlap on the edges. 20% should be sufficient for what you need. Payload settings, this is where you can choose single, triple, or double return. I recommend always flying at dual return to start with. Again, if you have overgrowth in the ditches or something, you may opt to go to triple return. Okay. Sampling rate, always leave it at the highest, so 240,000 points per second is what it's going to collect with LiDAR. Finally, the scan mode, repetitive is that narrow beam back and forth. Non-repetitive is that spirograph spray. It's like difference between painting a wall with a paintbrush versus a spray can. You're going to lose accuracy with the spray can, but get a better broadcast. However, at the detriment of your accuracy. So I would say for your transportations, you're going to want typically a repetitive mode. Again, you can experiment it, and I'll show you some differences. I've got a site that I've flown the same way twice and kind of show you what we've done. And then RGB coloring, you want to color, and people want the colorized point cloud, so we're going to leave that turned on. So at this point, it takes photos as it scans, but the photos are only there to colorize the point cloud. You can throw them away later. Hit save. It's ready to go. So this is the mission. It's going to go here, the blue start. It's going to rock back and forth 4 times. It's going to jump back to blue start, scan about 1,000 feet down. It's going to stop. It's going to shake itself up again right here. And it's going to go down, turn the corner, come back. Now that motion, change in motion counts as the shake up, so it doesn't come back. It does another IMU one up there, and then it always does it at the end. Okay, that's your scan route. I know you're gonna forget every single thing, but I'm gonna make you guys make this mission when you get on site. Alright. I think we probably can do this to death, so let's go out and